Today, we're going deep into a really fascinating topic: how artificial intelligence is being taught to read and understand one of the most vital signals in our bodies, our very own heartbeat. So, let me just start by asking you something. Imagine an AI model gets a near perfect score on a medical test, like 99% accuracy. Sounds amazing, doesn't it? But here's the real question: would you be willing to trust it with your life? Well, you might think the answer is an obvious yes, but as we're about to find out, it's way more complicated than that. In fact, that super high score, it can sometimes be incredibly misleading. To really get why a high score isn't the whole picture, we've got to take a step back and understand how we listen to the heart's electrical song in the first place. Okay, so for more than 100 years, the absolute gold standard has been the electrocardiogram. The ECG. It's a test that just records the electrical pulses of your heart. It's so foundational to medicine that its inventor, Willem Einthoven, actually won a Nobel Prize for it way, way back in 1924. But here's the catch. Reading those ECGs has always been up to human experts. And that process, well, it's slow, it's definitely prone to human error, and forget about trying to handle millions of them at once. It just doesn't scale. Now, this is a problem that is practically screaming for an AI solution. And that's where AI steps into the picture. The promise here isn't to replace doctors, but to give them a superpowered partner that can analyze ECGs with incredible speed and accuracy. Which brings us to this really cool study. They wanted to answer one single, incredibly important question. If we're going to put AI in a clinic, which one can we actually rely on? So they basically set up a competition to find out. So the job for these AIs was pretty straightforward. They had to classify ECGs into 3 buckets that doctors use all the time. You've got normal, that's easy enough. You've got abnormal, which is a clear sign that something needs a closer look. And then there's the really tricky one, borderline. That's the gray area where you're not quite sure what's going on. Now, this is where the researchers got really smart. Instead of asking the AI to juggle all 3 categories at once, which is pretty complex, they broke the problem down into 2 much simpler questions. First question, is this ECG abnormal or not? Second question, is this ECG normal or not? It's a clever way to help the AI focus and hopefully do a better job. All right, the stage is set, the rules are clear. It is time for the great AI showdown. Let's see which one of these models can actually read a heart the best. So in the ring, we've got a few different types of AI, and they all think in different ways. In one corner, you've got the heavy hitters, the neural networks like CNNs and DNNs. They're kind of modeled after the human brain. And in the other corner, we have what are called tree-based models. Think of these as super detailed flowcharts that make a ton of simple yes or no decisions to get to a final answer. Okay, round 1. Telling the difference between abnormal and everything else. The race is pretty tight, but you can see the gradient boosting classifier, that's a tree-based model. It just edges out the competition with about 68% accuracy. So, point for the tree-based models. All right, now for round 2, separating normal from the rest. And whoa, this one isn't even close. The random forest model, which is another tree-based AI, just crushes it with over 71% accuracy. Another big win for the tree-based AIs. So, based on accuracy alone, the verdict seems crystal clear, right? The tree-based models are the champions. They ace the tests. But hold on, this is exactly where the story gets really interesting and a little bit concerning. See, to really trust an AI with something as important as your health, you can't just look at the final grade on the test. You have to dig deeper and look at how it actually learned. Which brings us right back to where we started. When lives are on the line, is a high score really enough? Is that the whole story? Let me put it this way. Think about 2 students in a class. You've got the good student who really studies, understands the concepts, and can apply them to new problems. In AI, we call this generalization. Then you've got the other kind of student, the one who just crams and memorizes the answers for the test. This is called overfitting. They might ace the exam, but throw a new problem at them and they totally fall apart. And this right here is the big twist of the whole story. Those high-scoring tree-based models, they were the bad students. Their learning curves looked terrible. They showed they were just memorizing. It was the CNN, even though it didn't get the top score on every single test, that was the only one that proved it had truly learned the material in a trustworthy way. And just like that, we have our trustworthy AI. It's a huge reminder that when it comes to medicine, how an AI gets its answer is way more important than the answer itself. So you might be asking, how can we be so sure the CNN was actually learning?
Well, we can literally peek under the hood and see what it was paying attention to, and what we find is amazing. It focused on things like ventricular rate and QRS duration. It was looking at the exact same stuff a human cardiologist would look for. It was learning to think like an expert.
Armed with this knowledge, the researchers came up with a really powerful system for the clinic. You don't just use one AI, you use two of these well-trained CNNs. The first one basically screens for anything that looks abnormal. The second one confirms anything that looks perfectly normal. You put them together, and what you get is a diagnosis that's not just fast, but one you can actually trust.
And all of this leaves us with one big final thought. As AI gets woven into everything, from our health to self-driving cars, are we asking the right questions? Are we looking past those shiny, impressive accuracy scores and asking the one thing that truly matters? Not just what did you learn, but how did you learn it?